right, so you typed this derivative in your calculator, and what did you get?
How do I type this in?
Okay, so when you type this in the calculator, right, you have to type in this. You have to type in d negative cosine of x, comma x. You know how to take a derivative on the calculator, right?
Right.
And if you're not in degrees and radians, you're going to get a very weird answer. So we need to also be in radians. Because calculus is rad.
And why do you get a different? Oh.
I'm expecting you to say
Okay, because
the answer is sine x.
how do I get out of this? Miss Muller, how do I make this menu go away?
Escape. All right, so what does this question state? This question states, show the graph of the function f of x equals negative 5x minus cosine x plus 7 does not have a horizontal tangent line. What is the slope of a horizontal tangent line? 0. So what am I trying to prove?
That the slope is not 0.
Right, but another name for the slope is the
Derivative.
The derivative. So I'm trying to prove that the derivative is not equal to 0. So in order to do that, I have to find f prime of x, which in this case will be, what's the derivative of negative 5x? Negative 5. The derivative of negative cosine is positive sine x. And the derivative of 7 is 0. So I'm going to set it equal to 0 to see if it'll ever be 0. Well, then this is sine x is equal to 5. Yes.
I got pi times sine x.
You are in degrees. All right. So sine x equals 5. I ask you, can that be?
No.
Why? You're right.
Also in between negative 1 and 1.
Right. So this is no solution, right? Which means f prime of x will never be 0, and therefore will not have any horizontal tangents. Okay, so you can set the derivative equal to 0 and see if it happens. And in that case, in this case, it doesn't. All right, so number 3 says, determine whether the statement is true or false. If the statement is false, give an example showing that it can be false. If h prime of x is equal to g prime of x, then h has to equal g. No. Can you tell me why? You're right. It is false.
Oh, because in one of them you can have plus you can add whatever that thing's called, just a number.
So let's do an example here. We'll say that h of x, a constant, yes. H of x is equal to x squared plus 7. And let's say that g of x is equal to x squared plus
9.
9. Okay, I heard 9 first.
Nope.
Are their derivatives equal? Let's see. H prime of x is equal to 2x, right? And g prime of x is equal to 2x, but then h prime is not equal, or h is not equal to g, right? But their derivatives are equal. So you're right, that's false. If h of x equals g of x plus d, then h prime of x equals g prime of x. What? Yes, it will, because if I take the derivative of this expression, what do you get? You get h prime of x equals g prime of x, and if d is a constant, which we're assuming in this case, that's going to be 0, so this is true. Because the derivative of the constant is 0. Number 5. If y equals pi squared, then dy dx is 2 pi. False. It is false. Why, Nathan?
Pi is a constant.
Because pi is a constant. I'll say pi squared is a constant.
Number 4, why do you know they're equal?
When I take the derivative on number 4, Griffin, the derivative of h is h prime, right? Equals the derivative of g, which is g prime, plus the derivative of d, which is a constant, and the derivative of constant is 0, so they are equal.
Okay.
Alright? Alright, what about 6? If y equals x over pi, then the derivative of y with respect to x is 1 over pi.
No. False.
It's true.
Wait, but I thought pi is 0. There's an x.
Okay, another way you can write this, you can say if y equals x over pi, that's the same as saying y equals 1 over pi times x. And what's the derivative of 1 over pi times x? 1 over pi. Pi is just a constant.
So when it's multiplied, you don't take it to 0?
When it's, well, you would say power down, right? Remember, what's the power on this x? 1 times this, which is 1 over, right? Times x to the 0, which is 1, which is 1 over pi.
Why do you keep pi in the denominator?
Pardon me?
Why do you have pi in the denominator if you take the derivative?
Because pi is, I don't understand
Um,
why. How would, let me ask you this question. Let me ask, how would the pi jump to the numerator?
well, no. Well, why doesn't it change to 0 if it's constant?
Okay, we could take, okay, so if we want to, there are two ways we could do this. We could do the quotient rule. You want to do that, or the product rule? Which would you prefer?
Quotient.
Quotient, all right. So we're going to use this and do the quotient rule. So y prime is going to be what? Ho, which is pi, d high, which is 1, minus ho d high minus high, which is x, d ho, which is 0, all over ho ho, which is pi squared. And this goes to 0, and then you get pi over pi squared, which is 1 over pi.
Thank you.
Yep. But for quickness sake, I would hope that you could get here. And this is, what if I had y equals 1/2 x? What's the derivative of that? 1/2. Why can't you see that this is just 1 over pi?
Yeah, I can.
Right? That's where I want you to be. And if you see the x over pi like this, I want you to think of 1 over pi times x. Can you do that? They're equivalent. See, this is why these are really good ones to do. All right, number 7. If f of x equals 5 times g of x, then f prime equals 5 times g prime of x. Is that true or false? Okay, why? Let's use the product rule.
It's true, because it's like the last one. Just because you always multiply it.
Okay, this is true, but let me explain why. If we have f of x equals 5 times g of x, the derivative of the left side is just going to be what? F prime of x. And let's use the product rule on the right. What's the product rule? First times g prime of x, plus second, which is g of x, d first, which is, if this is the first and this is the second, what's the derivative of 5? 0. So the second half of the product rule will always go to 0 when you have a constant. That's why I always say the constant goes along for the ride. So this is true. Do you see that now? If f of x equals x to the n, then f prime of x equals x n minus 1.
False.
Yeah, I'm so glad you all said that with the ringing endorsement. Why? Because what is true? F of x equals x to the n. Go ahead. Tricia? Was it you I was hearing? Or Kate? Or Natalie? Or Maggie?
It's nx to the n minus 1.
Right, I'm sorry. I was too caught up in the writing. It was a female voice. At least I didn't call on a guy, right? That would have been embarrassing.
Thanks.
Honestly,
It would have been more embarrassing.
I get it.
Considering we're on tape.
Oh, good.
All right, moving right along. Here we go.
Is this for the people who are upset?
Yes.
Hi, Sam. Hi, Caroline.
Sam, you're soft.
Be nice. All right, here we go. Let's work some problems. Now, they're telling us that g is 32 feet per second squared. Okay, well, obviously it's negative, right? Because it's working downward. A projectile is fired vertically upward on Earth from ground level with an initial velocity of 16 feet per second. How long will it take for the projectile to hit the ground? Well, the first thing we need is an equation, right?
Right.
Does it give us an initial position?
Yes.
Okay, 0, right? We're going to assume it's 0. So since it's vertical motion, I'm going to say y, oops, it helps if I have ink. Y of t is equal to negative 1/2 at squared, right? But a is, in this case, 32. So this is negative 16 t squared plus my initial velocity, which is 16 t. Now this is asking me, how long will it take to hit the ground? The ground is a position, isn't it?
Yes.
What is the position on the ground?
0.
0. So I'm going to set my position function equal to 0, and I'm going to take the liberty of factoring out a negative 16t, and then I'm left with t minus 1, right? And so it's out on the ground at t equals 0 and 1. So how long will it take? 1 second. I'm thinking of the projectile vomit question. Okay. How high will the projectile go? It's at the maximum, that's right, because this is a parabolic shape that does this. And if you're thinking about the graph, that's 0 and this is 1. Now, your logic should be, well, I might already know the answer, y of t, right? Because it's going to be halfway, right? But we have to use calculus to justify our answer.
Find the velocity and then find the
Yes, so we're going to find the velocity, which is the v of t function, but the velocity is the derivative of position, which is going to be negative 32t plus 16. And I'm going to set that equal to 0, as Griffin stated. And that's going to be 32t equals 16. T equals 1/2. Our instinct was correct, right? It's going to be at t equals 1/2 because parabolas have symmetry. Now it says, how high did the projectile go? Got to plug it back in the original. So I want to know s of 1/2. All right. Now this is where,
Why'd you use S?
because that's position typically in calculus, and I should have used y here. This is y of 1/2. And it's Monday morning. That's in my defense. All right. So I need a calculator over here since I lent mine out.
Nathan, it's like you ruined the presentation.
Somebody sit over here. You gotta bring your notes. 16, and we're going to have to use x here. It's negative 16 x to the second was plus 16x. Enter. And then in y2, I like to put in the velocity function, which was negative 32x plus 16. Now let's go for broke here. Press enter one more time. And let's put the acceleration function in y3. I always like to do this because it's really easy to reference. Okay, so we want to put in negative 32, right?
Yes.
Okay, good. Now, we're going to go home, press the home key, and we want the position at 1/2. So we want y of, so you type y with parentheses, of 1/2, right? y1, I'm sorry, we should put y1. That's my bad, right there, 1/2, right? That's the position evaluated at 1/2, right? And we get 4. All right. Oop. All right. It's going to be ornery. I'm going to work around it, right? There we go. So that equals equals 4. So that's how high it went. Which is also the vertex of the parabola, right? Everybody follow that? All right, so let's do the next problem. A helicopter drops a package when the helicopter is 200 feet above ground. How long will it take the package to hit the ground? All right, well, I need an equation first. Now, is this vertical motion or is this horizontal? Vertical. So let's make our equation. Y of t equals, am I in feet or meters? Feet. So that's going to be negative 16 t squared plus 200. Good, because if it's being dropped, I'm assuming it's not being thrown out of the helicopter, right? Get to the ground really fast, right? We're not giving it any initial velocity. All right, so how long will it take for the package to hit the ground? Long is the signal that we're solving for. Time, and the ground's position is 0. So we'll set our position function equal to 0, and we'll get negative 16 t squared plus 200. And then we'll say 16 t squared equals 200. And I'm going to go over here and say t squared equals 200 over 16. So t equals plus or minus, this is going to be 10 root 2, right, on top, over 4, which is 5 root 2 over 2. Now, I did that in my head, right? Are we okay with that answer? Seconds. Well, shouldn't it just be positive? It will be positive, right. All right, and so we're going to have Ms. Schuyler over there calculate what that is for us.
Oh, 5 root 2 over 2.
Yeah.
What is square root?
Second root. The root button is over by the multiplication. There we go. Divided by 2, and then you go diamond, enter. What is that, about 3.5?
4.
It's not going to let me paste, so I have to paste the weird way. It's okay. I'll get it in there. All right, what is the speed of the package at impact? Speed is now,
V of t.
well, it's the absolute value of v of t, but first we need to find the velocity, which is going to be
The
derivative of the position, which is
negative 32 t.
negative 32t, because the derivative of 200 is 0. Now what we want is we want the speed. Now if I plug time equals 5 root 2 over 2 in there, it's going to give me what kind of number?
Negative
negative. So we want the absolute value of v of 5 root 2 over 2, and that'll give us our exact answer. Yep.
How do you know that you didn't just do it wrong?
I'm sorry?
Like, how do you know you didn't just do it wrong if we could take, like, the absolute value?
Speed is directionless, so speed is always positive.
No, I know, but, like,
Are you talking about the velocity being negative? Are you, what,
So
what,
you can
what
just-
part
you
of it
can
is
just-
that
you
you're
can
worried
just-
about being wrong?
you can just always take the absolute value. Like, would you always have a negative times a positive, and then you have to take the absolute value?
No, not, well, in this case, when we're dropping, velocity is always going to be negative because its direction is negative, right? It's going down. So velocity will always be negative, but its speed is a scalar quantity and just is the magnitude of that, which is positive. All right? So we're going to go back to Skylar. Are you ready?
I think so.
Now, let's say I wanted to find the absolute value of that. Can you go all the way to the beginning of that statement? All right, and then go second alpha lock. Do you see that?
Yes.
And then type ABS, which is ABS is over, and then alpha again. Nope, go back. I'm sorry, then hit alpha and then parentheses. There we go, and then enter. And that gives me 80 root 2. And then now do the diamond, and we'll get the, you're a great calculator driver there.
Thanks.
Might have to make that your permanent job in a good way. Oh, it's not going to let me do it that way. Train me, I guess. Everybody all right with that? So this is equal to 80 root 2. What are our units here? Feet per second. Or approximately 113.137 feet per second. Now, in AP Calculus, you have to have 3 places after the decimal.
What?
Yes, I know. It's annoying, but that's what their rule is. A man drops a quarter from a bridge. How high is the bridge if the quarter hits the water 4 seconds later?
Do we have to add
Do you think
16?
you, like, flipped it on this?
I know. What do you mean? Why would I add 16?
Isn't that the velocity function negative 32t plus 16?
Well, no. What's the derivative of 200? We don't have a 16.
Oh, I was looking at the wrong.
Yeah. You would if we had a 16t in there, but we don't, right? You're good to think about that. All right, a man drops a quarter from a bridge. How high is the bridge if the quarter hits the water 4 seconds later? Well, what do I not know?
Y of t. Or y of 4. Position.
Right.
Initial value.
But I can come up with a y of t, right, which would be, and this is in, we're going to do feet. So we'll say that this is negative 16t squared. Does it have it? He's dropping it. So does that mean there's no initial velocity? But we don't know how high. So I'm going to say plus y naught. Why not? Use why not. So we don't know it. But I know that it's hitting the water 4 seconds later. So I have a point in time, don't I? I have at 4, what is my position? 0. So may I use that to solve for why not?
Of course.
Why not? So we'll say 0 equals negative 16 times 16 plus why not? And 16 squared is 256. Right?
Right.
Okay, so the bridge is 256 feet high. Now, they didn't suggest to us not to use meters, right? So we could have done it in meters. But I figured I'd use feet. Number 4. A projectile is fired upward from the ground level. A projectile fired upward from the ground level is to reach a maximum height of 1,600 feet. What is its initial velocity? Well, it's going to be a y of t equals negative 16t squared. Now, they're saying it has an initial velocity, so it's going to be plus v naught times t plus what's its initial position? 0. Good, so I don't have to show that. Now they're giving me a maximum, right?
That would be y of t.
So it's going to be at some time t.
0.
Do we know that time?
No, we have to solve.
We don't. So I'm going to call this t. What do I do? The derivative, yes, y, you're right, yeah.
So you find the velocity function and set that equal to 0.
Yes. Right, because the velocity, if we're doing the projectile motion, right, is 0 at its maximum. We all right, Kate? So what is the derivative of wise people, you? Negative 32t plus v naught. Uh-oh. Let me ask you this. Do we have 2 equations and 2 unknowns?
Into what?
2 equations and 2 unknowns. Because I know that this is going to be 1,600. Do I have 2 equations and 2 unknowns? We do indeed. So what must we do? We must reach into the deepest part of our brain and solve a quadratic linear system. So should we do substitution? So what should I say V naught is?
32t.
Using substitution, I'll say V naught is equal to 32t. We can say then that 1,600 equals negative 16t squared plus 32t squared, right? Because 32t times t is 32t squared. So we get 1,600 equals 16t squared. Wow, these numbers are really nice. T squared equals 100. So t equals plus or minus 10, but I want the plus, right? So at t equals 10 seconds, the projectile is at its maximum. But is that what the question asked? No, you're right. The question asked, what is its initial velocity? But I have a relationship, don't I, between the initial velocity and time, right? So I can solve for V naught by saying V naught is equal to 32 times t. So V naught is going to equal 32 times 10. So that's 320 then. Feet per second is the initial velocity. So sometimes you have to solve a system, which is uncomfortable, right? Yeah, no, I didn't think you'd like that. All right. Moving right along. Now I'm working a bunch of these so the homework doesn't seem so onerous. Yes, very. The equations for free fall at the surfaces of Earth, Mars, Earth, and Jupiter are the following. How long will it take a rock initially at rest in space, in a space capsule, over the planet to reach a velocity of negative 16.6 meters per second? Well, I have position functions, right? So how do I get all of the the velocity functions? I have to take free derivatives, yes. So this is going to be velocity on Mars of t. All right, Skylar, since you have the calculator open, negative 1.86 times 2.
Negative 1.86 times 2.
Mm-hmm.
Negative 3.72.
Negative 3.72 t. All right, and then the velocity on Earth is going to be, that's going to be 9.8, right? Negative 9.8
Yep.
t. And then the velocity on Jupiter, you're going to have to do that. Is that going to be negative 22.88?
Yes, it is.
All right, and I want to know when each will reach a velocity of negative 16.6. So negative 16.6 equals negative 3.72 t. So t is going to equal something here. Negative 16.6 equals negative 9.8 t. So t will equal something here. And then negative 16.6 equals negative 22.88 t. So t is going to equal something there. So let's get your calculators going. Skylar, you do the first one, Luke, you do the second one, and Nathan, you do the third. What do you get, Skylar?
I got 4.462.
All right, Luke.
Negative 1.69.
No, it should be positive, right?
Oh yeah, positive 1.694.
Okay. Nathan.
0.726.
I need, okay, good. All right. Obviously, which one gets to the surface faster? Jupiter. Because it has the highest acceleration, doesn't it? If you think about it. And then Mars, it's going to be a little pokey getting to the surface. Or it's going to take its little time. All right. Number 6, a projectile is fired vertically upward with an initial velocity of 96 feet per second from a 256-foot high tower. How long will it take for the projectile to reach its maximum? Well, I need a position function, right? Which is? Somebody help me with that. I'm getting used to these, I hope. Y t equals?
Negative 16
Right?
plus minus 16 plus 256.
Well, it's not going to start up there. It's going to start on the ground. Projectiles fire upward. Maybe it is. 250 plus 256. Yes, it is. You're right. Sorry about that. She's absolutely correct. From tower. There is the clue, right? What is its maximum height? How do I find a maximum height? Velocity equal to 0. You guys are getting that. I love it. Okay, so v of t is the derivative of position, which is negative 32t plus 96. Set that equal to 0. So 32t equals 96. So t equals 3. Now that's not the question though, that's when it gets there.
See, it's
Skylar's going to do that for us. Now what are we going to do? Let's go to diamond y equals and put our functions in there. Because I want this to be a really good habit to have here. So what is it? It's negative 16 x squared plus 96 x plus Patricia's accurate 256. Right? And the velocity was negative 32 x plus 96. And obviously the acceleration is negative 32. We may not ever use this for these problems, but okay. All right, so we're going to go home. And we want to know the position, right, at 3. So we want y1 of 3, because we always put the position function in y1. Enter 400. Full 100. Now it's behaving because I didn't lock it in place. Fascinating. So this would be at 400 feet is max height. How long will it take the projectile to reach its starting position on the way down? What did it start at? 256. So I want to know 256 equal to y of t, right? Which is 256 equals negative 16t squared plus 96t plus 256. Is there a way to do that on the calculator?
Yes.
Yes, so let's go back. Skylar, what we're going to do is solve, right? Okay, second. Quit. Or go home. Go home. Yeah, I'm sorry. Clear. And we're going to F2, solve.
Wait, F2?
Yeah, isn't that where the solve? Yeah. 256 equals, what do we want it to equal? Y1 of x. Yes, very nice. So we don't have to retype it, right? No. Go back. Of x. It has to be parentheses of x.
Oh.
Comma. What are we solving for? X. And then close parentheses. God bless you. How many answers do we expect? 2, because it's a quadratic.
I accidentally already hit enter.
That's fine. She was trying to hide it from us, but that's all right. We already knew the answer, so. Because we got a bunch of smart APers in here, which is cool. Look at all this physics y'all are doing. Woohoo! All right. How long? Now, do we want it to be the t equals 0 or the t equals 6? T equals 6 seconds. Projectile will be at 256 feet again. Now, based on symmetry, we probably already did that. All right. Part D says, what is the velocity when it passes the starting point on the way down? So what do we want to know then? Now, what do we want? We want to know V of
6.
right. So we want V of 6. Now on the calculator, wait till I get there. Where's velocity? Y2. So we want to clear that out. We want to do Y2 of 6.
Do I need to solve?
No, just we want to know the value of Y2 of 6. No, we don't have to solve for that. We already. All right. So that's the velocity, right? Because it's got a negative sign, but we're all right with that. It's not asking for the speed, is it, in this question?
No.
It's asking for velocity, so having the sign on there is perfectly okay. SIGN, right? So this is negative 96, and this is going to be feet per second. How long will it take to hit the ground? equation with 0, we want y of t equal to 0, which is going to be negative 16t squared plus 96t plus 256. But I'm going to let the calculator do that by solving for me.
Solve.
Yep. 0 equals, where's position? Right, y1 of x. We're solving for x, so comma x, close and tray. Now, -2, let's talk about that. Can we have negative time? Yes?
Yes.
That could be 2 hours before. It took me 2 hours to walk up the stairs to get the projectile into firing motion. Because I'm an old lady. Right, so -2 in time language is going to be like, or 2 seconds before, right? Well, I didn't run 256 feet in 2 seconds, could I? That would be the flash. Do you see what I'm saying? So you can have negative time. It's relative to when you started. Does that make sense? But we want the 8, right?
Right.
So what was the question again? I forgot.
How long will it take to hit the ground?
8 seconds. I just didn't know if we had to plug that into something else. Projectile will hit the ground at t equals 8 seconds. Okay, what will be its speed when it impacts the ground?
Take the absolute value.
That's right. We want to know the absolute value of v of 8. Good. So we're going to go back to the calculator. Alpha A, good. Abs, ABS. Alpha, one more time, good. Parentheses. Now where is the velocity? Y2. We want Y2 of 8, I believe. Yes. And that's 160. This calculator is an amazing piece of machinery, yes?
Yeah, I don't know how it works.
It's really cool. Okay, so that would be 160 feet per second. Now with these numbers, I would expect you could probably do this without a calculator. I'm just showing you how to do it with a calculator.
What?
I know. Evil, Mrs. Muller. Here we go, moving right along. Sometimes we have graphs for position. And we want to graph the velocity. Well, what is the velocity with respect to position? It's its slope. It's its derivative. Okay? So what is the slope from 0 to 1, 2, 3, 4, 5, 6, 7, 8, 9? I mean, to 8. Wait, 1, 2, 3, 4, 5, 6, 7, 8. No, to 7. 0. Okay? That takes me a while. I'm going to do it in green. So on the velocity graph, you can say the velocity is 0 here in that 1, 2, 3, 4, 5, 6, 7. It's open here. Why do I have that open? Can you take the derivative here?
No.
Right here is what?
Change. Corner.
It's a corner. So it's not differentiable at t equals 7 because it's a corner. So you have to leave that open. You can have a solid dot here because you don't have anything going on this side. Okay? All right, what about the slope from 7 to 11? 7, 8, 9, 10, 11. Thank you. And then this is 12, right? 13, 14, 15, 16, 17, 18, 19. Okay, what's the slope from 7 to 11? Well, the run is 4, and the rise is that 6?
6.
So it's negative
3
3 halves. So I'm going to go to negative 3 halves and put an open dot here, and then all the way to 11. I really wanted these to be lined up. 1, 2, 3, 4. Another open dot, right? Because it's at a corner again. Yep. All right, and then what is the slope from 11 to 12?
0. Oh wait, 4, 12.
6.
6 over 1, so it's 6. It's a really skinny line there. These are both open. Okay, now what is the slope from 12 to 19? 0. So 12, 13, 14, 15, 16, 17, 18, 19. Both open again. And then what is the slope?
1.
It looks like it's 1, is that right?
That's what I got.
Yep, I think it's 1. The rest of the way. And you can have a solid dot at the end because
There's nothing to the
there's nothing after it, right? Okay, everybody okay with that? Remember, the slopes to the position function are the velocities, okay? What about speed? Remember, what did we say speed was?
absolute value.
Right, so what do I have to do to these?
Just move the negative 1.
Move the negative 1 up to the positive location, but other than that, they're going to be the exact same. So it's going to be solid here, all the way to 7. It's still open. And then the 3 halves one is going to go up from negative 3 halves to positive 3 halves. And then it goes back to up to 6. Back to 0. And then to 1. So if you have the velocity graph, it's really easy to go to the speed graph. You just take all the negative values and force them positive. All right, and it says, when is the particle moving to the left? Now, I would do a sign chart for velocity. Now, what do I mean by a sign chart? So the velocity is what here? It's 0, and then from here to here it's negative. And it's undefined here. We need to write that because it's not defined there. So this is 7 and this is 11. And then at 12 it's, between 11 and 12 it's positive. And then from 12 to 19 it is 0. And then from 19 to, what was the last number? I'll check. 19, 20, 21, 22. 22, it is positive again, right? Everybody following me, I hope?
Not really.
What?
What is this for again?
This is the sign chart.
So like,
Because sometimes I get lost.
undefined. I thought that was like shaded lines. I didn't.
It's undefined, right? Because there's
they're
no,
open. Yeah.
right? It's
got
not equal to 0. It's undefined.
it. Yeah, got it.
When did I say particles were moving horizontal. This is horizontal motion. So this is, what is it doing here? It's stopped, right? So it's stopped. Here it's moving left, and then it's moving right momentarily, and then it's going to take a stop break, and then it's going to move right again. You can read it right off the sign chart, can't you? This says, when is the particle moving to the left?
From 7 to 11.
Right, so from 7 to 11, you use the interval notation, and then you go since. How did you know that? Using calculus. V of t,
It's greater.
no, it's left is
Less
less than 0. There we go, that's how you know. Then it says, when is the particle moving to the right? 11 to 12, and you don't have to use the union. When? 19, 22. Now how did you know? Using calculus, since V of t is greater than 0. Good. When is the particle standing still?
0, 7,
0 to 7,
and 12 to 19.
comma, 12 to 19. Since V of t is equal to 0. Yes, sir?
Would you put a bracket at the beginning of 0 to 7?
You can.
Okay.
It's like increasing, decreasing. We don't really know.
Yeah, okay.
When is the particle moving the fastest? How do you know that?
That's when the velocity is greatest.
Okay. All right, so can you do it pictorially now? Do you get that? Any ways that's easier?
Can you do it what?
Pictorially, looking at the graph.
Oh, picture.
I should have said graphically.
I thought you said Victor.
No, no, no. I could have been from this side. Now, they're giving us the velocity, whose derivative is acceleration, which means I need to have the slopes again, right? So I'm going to say that this is 2. I hate it when I change colors. I have to change my pen thickness every time. I want it to default to skinny. All right, so that's 2, 3, 4, right? That's where it changes. And then 5, 6, 7, is that 8? 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. This is just 22 down here at the end. Okay. Is that,
Right 2.
what?
Are you just doing like
You know what, I'll erase the 2, but if I do that, I lose my thickness. That's a 0.
okay.
I need to figure out how to default to something different. All right, well, I need to know the slope, don't I, from 0 to 4. So that's 1, 2, 3, 4, 5, 6 high, 6 down. That's 12 over 4, which is 3. Oops, but it's what sign? All right, and then the slope between 4 and 8? It looks like it's 1, yes? the slope between 8 and 14? Is 0, you're right. And then the slope between 14 and 17.
3.
Yep. Let's see, 1, 2, 3, 4, 5, 6. Yep. 3. Positive 3. And the slope from 17 to 22. That's going to be 4 and 6 is 10, is 5, it's negative 2. Yep. You follow? When does the particle reverse direction?
It just may change.
Okay, let's do a velocity chart. Is that all right? Because I get lost in this beautiful picture. Okay, so V of t, sine chart. At 2, it's got a 0. Where else? Looks like 15. It's got a 0, and then it's got a 0 at 20. Everybody follow that? The 0 for the velocity function is at 2 and at 15 and at 20. What is the sign of the velocity to the left of 2? SIGN. It is positive, good. And then it's negative all the way till it gets to 15, and then it goes positive, and then it goes negative until it gets to 22. So the question is, when does the particle reverse direction? And we know, right, that it's going, let's do our, this is, what, you mean undefined?
Like the stop left, right?
I don't have this, well, I'm about to right now. This is right, this is, I'm not going to put stop when it's 0, will you remember that? And then this is moving left, and then it's right, and then it's left again. So when does it change direction? At 2, 15, and 20, right? Why? If t equals 2, 15, and 20, since V of t, can you say changes signs? Does it matter if it went from positive to negative or negative to positive? It just changed signs. When is the particle moving at a constant speed? Constant speed is when the acceleration is 0.
So it's from 8 to 14.
And that is from, you said 8 to what?
14.
And I put the cents in front. When is the particle moving at its greatest speed? Now remember, what is speed? Okay, so I'm going to do the absolute value of this one. That's at 3, right? 1, 2, 3. So I'm going to draw the speed graph, okay? And this goes down to 3, goes across to here. And then it goes from here to here. Wait, it goes from here to here to 0, and then back up again, back down again, and then goes up here. So what did I just graph in red? the speed function, and I'm going to write that. When is this particle at its greatest speed? 0, 4, and 17. Do you see that it's here, here, and here? Oh. It's at t equals what? 0?
0, 4, and speed t.
And I would say C graph. Oh, crud. I messed up all my other stuff. But I can adjust. Look at that. Are we following all of this? Look at that, I fixed it. Except now I gotta fix this whole. Okay. Oh. Where was that one? Help me.
1.
Oh.
This was at 1? All right, so what was it? Where was this one?
For negative 3.
This one?
Negative 2.
Thank you. And this one? Is that 3? Shoot. Did I miss? No, we're okay. All right, moving right along. I'm going to skip this one because I wanted to do some particle motion of a calculus nature. This is from the exam 1969. I figured I'd start
Oh my
the
gosh.
very first one I had, okay?
1960.
This
That
is
is
number
crazy.
2. There are 6 free response questions. Number 2 is one of the least, not as difficult ones.
And that's like for all tests?
It is, and I didn't.
Yes,
Yeah, you can write it.
they did this in 19, I swear, they did it without calculators. We're going to do it without calculators. Okay, here we go. Now, the particle moves along the x-axis in such a way that a position time is given. So they're giving us a position. It's moving horizontally, so they made it x. Part A says determine the velocity and the acceleration of the particle. Well, what do we have to do that? That's right. So part A is really nice. If x is equal to 3t to the 4th minus 16t cubed plus 24t squared, and I'm going to notice this is a closed interval, okay? Just note that. What is b? We've got 4 minutes. 12t cubed,
Minus
48, t squared plus 48t, right? Acceleration,
36.
36t squared,
Minus 96.
t plus
Plus
48. Okay? That's, you get 2 points for that out of 9 so far. So next part B says, when is the particle at rest? That's right. So the velocity equals 0 when particle is at rest. So what am I going to do? I'm going to take b of t and set it equal to 0, which is, can I take a 12 out of everything and a t? Yes?
Yes.
I get t squared minus 4t plus 4. Everybody follow that? So 0 equals 12t, and this thing does factor. This is t and t, Dynamite. Minus 2. So t equals 0 and 2 with a multiplicity of 2. The particle is at rest at those two locations. Now I'm going to do a sign chart because it's going to help me maybe with future questions. So it goes from -5 to 5, right? And it has a 0 at 0 and at 2. What is the graph of this velocity? It looks like a cubic, right? And it bounces at 2 with a positive end behavior like this. So it's going to go like this. And if I were to do a sign chart, I know it's negative, positive, and then positive, right? So part C says, at what values does the particle change direction? Can you help me with that? Particle changes directions at t equals 0. Since v of t changes signs. Why didn't I choose 2? What's happening is the particle says, okay, I'm moving left at -5, and then I'm going to stop at time equals 0, and then I'm going to move right until I get to 2, and then I'm so tired I'm taking a rest, and then I'm going to go positive again. You see? So it doesn't change direction. Part D says, what is the velocity when the acceleration is first 0? Well, do I know when the acceleration was first 0? So acceleration I got to find, which is 36. Sorry. A of t equals, what was it? You're going to have to help me. 36 t squared plus 96t plus 48. Set it equal to 0. I can factor a 12 out of everything. And then I get t squared minus 3t squared. 8t plus 4 equals 0. Okay, so it's going to be 12 times 3t and t. They have to both be negative.
Good morning. Please stand for the morning prayer and Pledge of Allegiance. If you're in the hallways, please stop. In the name of the Father, and the Son, and the Holy Spirit, amen. Our morning offering to start the week. O my Jesus, through the Immaculate Heart of Mary, I offer you my prayers, works, joys, and sufferings of this week. For all the intentions of your Sacred Heart, in union with the holy sacrifice of the Mass throughout the world,